What's up, YouTube? Good afternoon. I'm Greg from GregsTutoringNYC at gmail.com. I'm going over the 2017-2018 SHSAT using the SHSAT handbook. If you guys need a copy, you can email me to get a copy because it's not available through the DOE anymore. I did all the English and all the math. In fact, I did all the grade 8 sections, at least on the Form A. So what we're going to try to cover today is the grade 9 math examples. All right? Give me 1 second. YouTube has given me a whole bunch of warnings, so I hope we're going to stay live. So the kind of sense of the math problems are going to change a little bit. You'll notice they're going to be using more exponents, more coordinate geometry, more things about volume. It's not necessarily that the questions are harder or more tricky or anything like that. They're just going to start using other things. There's no guarantee again that this is what they do in grade 9 versus grade 8, because some of the examples could cross between the two of them. And a few of these here you might say, wait, why is that a grade 9 problem? And that's exactly kind of what the situation is. All right, so this I think there's 13 questions here. Let me see here. 7. Actually, I'm not sure I printed all the pages out. Yeah, there's 13 questions. Not quite sure how to do it, but we're going to at least split it up into 2 and maybe even 3 parts. So I'm maybe going to do 6 and 7 or something like that. Or we're going to do like three sets of 4, just depending on how I talk about it. My head's bothering me again today, so I'm not sure I'm completely up to this anyway. Plus, I have other stuff to do right after this. So we might go half an hour. Let's see what's going to happen. So why don't we just jump into this and see where it leads? I see a bunch of people logged on. Hello. You could say hello and try to answer the questions as we go over them. If you prefer to remain silent, that's fine too. So let's just jump into this. The directions, make sure you're familiar with the directions. And notice that the grade 9 directions are pointing you to page 61 through 114. So don't get lost in that. And remember, most of the grade 9 SHSAT is the grade 8 SHSAT. A lot of kids keep asking me, what's on it, what's on it, what's on it? And they don't want to do any grade 8 material at all. You have to. The grade 8 is a subset of the grade 9 SHSAT. In fact, it's a huge, large subset of it. I hate to give numbers, but at least 75% of the grade 9 SHSAT is probably grade 8 stuff. Even if it's 50%. You know, I'm not sure how to statistically get the right number here, but if it's certainly 50% of it. All right, so that means a lot of the material you have to be prepared for in grade 8 material. Don't just look at the 2 pages of grade 9 here and say, like, I don't know what to do. You have a lot to do. There's a lot of topics that can cover. This is only 13 examples of 100 different subtopics that can be done, right? It's the same in the other part. There's 57 questions, but that's only 57 out of hundreds of subtopics. And even the 57 they choose, for instance, question number 4 on this one is going to be about exponents. There's so many different variations of an exponent question that there's literally hundreds of possibilities possible here. So you need to know the fundamentals, the core stuff, and you need to know really what they're asking you about a lot of this stuff. All right, so with that in mind, let's jump into question number 1. Let me just make sure we're live. Yes, we are, and it actually says I have an excellent connection. And let me make sure that my streaming thing is set up right. Okay, so 1, it says, assume S of X equals the sum of all positive even integers less than or equal to X. What is the value of S of 7? So this is using function notation. Normally, previous to this, you may have said Y equals, say, MX plus B as an argument. So all they're doing is saying F of X here. Instead of Y, they're using F of X. And the rest would be the same. So if I have F of 2, that would be 2m plus 2, like that. In other words, we're just going to replace whatever the argument of the function is we do a text substitution wherever it goes. And that text substitution has to honor PEMDAS. So if this was like, 2 plus 3 squared or something, you have to square. If this ended up coming in as a 2, you would get 2 squared. Okay, in that case, if it was n. So you would get 4 for that. So you have to honor parenthesis and other things like that as well. All right? Because you could also do something like f of 3 plus 1. So when you have a scenario like that, and it's something like n squared, this is not 3 plus 1 squared. It's not that. Okay? This is 3 plus 1. That whole argument squared. Okay, so in this case, we don't have anything as complicated as that, but I'm only mentioning that because we're going to be covering these 13 examples. And again, they're not going to go through all the pathology just because of the way they present the handbook to us. But you have to accommodate all those things. And again, if you're taking the grade 9 SHSAT, you had better understand these kind of things. If you don't, please go look them up. And that's true of every topic we're going to cover here. It's also true of your grade 8 stuff. In other words, the next question is about square roots. If you don't know how square roots work and exponents work, you're either going to get question number 2 wrong, or you're going to take too long to solve it. Okay, and you just, again, you have a minute and a half to solve these problems, and you want to solve most in about 30 seconds, because you want the extra minute on each of these. So when you finally get to a problem that really is truly confusing, really that's deeper, really that might take 5 minutes. Okay, so you have the extra time, or even just to go to the bathroom or something during the test. Most kids do not finish the SHSAT. You normally have 3 hours. If you have an IEP or 504, you have double time. So you have about 6 hours. But most kids taking the 3-hour one don't finish. Okay, which is not good because you're not going to get credit for those, and you don't want to spend the last minutes scrambling to fill in the extra bubble answers that you didn't fill in just randomly, hoping you arbitrarily get some right, and you will, but that's not a good strategy for taking the test. All right, so we're going to shoot for here of S of 7, okay, and it's telling us, it's not giving us a formula like the mx plus b here, but it's telling us that it's even integers less than or equal to x. Well, if x was 7, right, so we get 1, 2, 3, 4, 5, 6. Those are our choices, and it's telling us even, so we have 2, 4, and 6. All right? And what we're going to do is add them up. So that's 10 plus 2 is 12. And that's what we get there. Let's see, were these presented? Yeah. So these are the first 2, I guess, are examples of grid-ins. So they're not going to give you a leg to stand on there. And you might argue, isn't this kind of easy? Well, if you never saw a problem like this, it's not easy. So that's one reason to at least have done the handbook examples to prep yourself for something like this. All right? So that's number 1. So the second problem is the square root of 16 times the square root of 196. So if you don't know that means multiplication at this point, you're in a bad position. There are some examples where they will not put this at all, and sometimes it will be an X, and sometimes it'll even be an asterisk. Okay, so there's different fonts they can use. Just try to figure out what's going on here. So if you know anything about square root or exponents, there's one solution where you can take the 16 and multiply it by the 196, because if I have the square root of a times the square root of b, that's the same as the square root of a times b. All right? But you don't want to do it that way if you can avoid it, because why do you want to multiply 196 by 16? That's a nasty number. So I think most of you know that the square root of 16 will map into 4. But most of you know what the square root of 196 is? Now, on just about every stream I've ever done, I've told you guys to know the multiplication table, especially the perfect squares, up to 20 times 20. All right? So some of you may not know what the square root of 196 is. It's 14. that should be right at your fingertips, at the tip of your nose, right? There's no computation to be here. Now, some of you can come along on the side and say, well, 10 times 10 is 100, and 20 times 20 is 400. So it's between there. So let's try 15. And if you happen to know what 15 by 15 is, you could check it. Otherwise, you actually have to multiply it out, right? So all this should be there. So you could still figure out that it's 14, because you're going to get a higher number here, and it's going to go less. You might try 13, right? And then finally, you'll get to the 14. So it's not a case that you can't do it, but this is a throwaway question. You just want to go square root of 16.4, square root of 196.14, and then multiply them. So you're going to double this, get 28. You're going to double it again, 56. Right? Multiplication by 4 means you double twice. So that would be a grid-in for that. These ones are a little different because I also give the advice that once you get your answer, you should feed it back into the problem. But in this case, there's not really a leg to stand on, especially on number 2, which just, if you computed those numbers right, they're going to get it. If you didn't compute it, you're not going to get it. All right? I'm going to skip number 3 for a second because number 5 also relates to geometric shapes, and I want to bring up a what do you call it? A reference sheet for you guys. So we'll do those two together. So let me bring number 4 over here. And again, if anybody has any questions, please ask. So we want to skip to this. So this is exponents. So this comes down to, do you know your exponent rules? By the way, in reference to 2 and 4, I did a whole bunch of live streams here, which I called lightning rounds. I hope to still get to do some more, but in a whole bunch of lightning rounds, go log onto my channel. By the way, like and subscribe. Like this video, subscribe to my channel. Look for lightning rounds and just play a bunch of them. There's a whole maybe 3, 4, maybe 5 or 6 even that were explicitly about exponents and about square root and cube roots and other things like that. So just to give a kind of a quick background, if I have something like P of 6 times P of 6, this, or let me use simpler numbers, P of 2 times P of 2, this means P times P, and so does this. So we end up with P to the 4th. P times P times P times P is P to the 4th. So what we're doing is we're adding the exponents. Okay? And if we were dividing, say by our P, if we have P to the 4th over P, that's P to the 1. We're going to do a subtraction, so that would equal P to the 3. Right? So when we multiply, we add the exponents. When we divide, we subtract them. Okay? So if we come to P of 12 times P of 0 over P of minus 4, there's a couple ways to approach this. One is to just say anything to the 0 power is 1. So we have P of 12 over P of minus 4. So up here we did 4 minus 1. So we're going to do 12 minus 4. Okay? And that's equal to 16. So the answer to this would be P to the 16th. All right? Oh, wait, sorry. We have to add the 1 in. So, no, sorry, it was a 0. So we get 12 plus 0. We could also, so if we kept that in, P of 12 times P of 0 over P of minus 4, we still get the same answer. We multiply the top and we still get P of 12. And the bottom still remains P of minus 4. So we still get P of 16. All right? So this one was kind of a no-brainer as well. So 4 would be H. All right? All right, so let's go back to 3, and we'll do 3 and 5 together. So let me bring three back on the screen. Actually, we might do these two problems and be done for today. Again, my head is killing me, and we can do bite-sized pieces of this. So the first thing we're going to do is look at the illustration. It's the same thing I do every single time. We have an XY coordinate thing set up here. We have a line MN, a line segment, and N is 5, 1, and M is 2, 5. Okay? Don't know where they're going with this, but we just try to make as much as we can out of it. And the bottom has the x-axis is labeled. If they're counting by 2s, make sure you make note of that. And the y-axis is also counting by 2s. In this case, there's a blank space between them. So let me do this. I'm actually going to bring up the actual thing here, so we can talk a little better about it this way. And the question can remain on the screen at the same time. So in some cases, they're going to give us this, so that's going to be 1. That's going to be 3, and so on. Sometimes that gap may not be there, right? So at least we have that gap here. So it says, so that's pretty much it. We beat the grid to death here. So let's go to the problem. It says, if line segment MN is translated 1 unit to the left to produce M prime, N prime, what is the area of the parallelogram NM, N prime, N prime? Okay, so what are they even talking about here? So they're talking about taking this whole line segment here and shifting it over 1. So if it goes over 1, we're going to have something like this. And they're telling us it's making a parallelogram. So we have basically M prime and N prime. Okay? So let's reread the whole thing together. MN is shifted over 1. It's translated to 1 unit to the left. We don't know if this is inches, feet, or whatever. So it's just units. Each square is 1 square unit. And we produce M prime, N prime. And what is the area of N, M, M prime, N prime? So this thing inside of here. So one solution is to discount. Okay? This is about a half. That's about a half. So that's 1. This seems to be messed up, so that's about 3/4 of 1. There's a quarter there, so we're up to 2 at this point. And then we're going to come down here and get this one, which is about 3. And we're going to come down here and get kind of another half of 1. So we end up with about 4. So we can make an educated guess there and see that it's probably not 6. It's probably not 5. It could be 3, but it's really over it. So 4 is your best answer, and you can move on along with that way of doing it. The other consideration is to actually compute the area. So we have a parallelogram, okay? And I think most people would say that because if we have something like a square, or a rectangle, let's say, normally the longer side is called the length, and the shorter side is called the width. So this is actually also a parallelogram. So is a square, where in this case the length and the width is the same. So we have, in this case, the area will be length times width. In this case, the area is side to the 4th, or side squared, sorry. And in both cases, we end up with square units. All right? So most kids, I think, are going to go with this. And that's how they're going to be led astray. Because some of you are going to be able to figure out that if we go 3 units over, if we use the original line, that's 3. And we go down 1, 2, 3, 4, that's 4. then the hypotenuse here is going to be 5, because that's a 3, 4, 5 right triangle, right? This would be a right angle here. And by the way, you could have done it by dropping down over here as well, right? That's still going to be 4, and that's still going to be 3 there. You could also have done the Pythagorean theorem and got 3 squared plus 4 squared equals, c squared, and this would have been 9 plus 16 equals c squared, and then you got 25 equals c squared, and then 5 equals c. Okay, so you have a couple of ways to do this. The best is just knowing this is a 3, 4, 5. And it told us it was 1 unit away, so we know the length of this is 1. So I think enough of you are going to use this here, the length times the width, and just do 5 times 1 and get 5, which would be c. Okay, that doesn't work because of the little slanting issue here. Because if we do that, we get a little triangle at the end of here, and if we do that, we get a little triangle at the end of here. And then the question is, how long is it from here to here? Up until then, because it doesn't actually meet it. So we know it's less than 5 then. Right? And the question is, if I take this and tack it on to the end of that, how much longer does it end up being? Is it 4? Is it 3 point something? Is it 4 point something? Is it like 4.9? Is it 4.1? Is it 3.9? We don't quite know. There is a way to calculate it, because if that's 1, we can actually get information about that. But it gets super ugly super fast. And we didn't even want to do this calculation, okay? Because you should have already known about 3, 4, 5 right triangles. All right? So what is the area of a parallelogram? What I'm going to do is bring up another slide here. So we're going to talk about what's the area of a parallelogram. I'm trying to see if all this fits on here and is legible. Let's make sure it gets in focus. Okay, yes, it seems to be. So here's the example I gave before. We have length times width. And it works for a rectangle, and it works for a square. But when we have something like this, where there's a slant, so to speak, it's not working the same way. And it's not working the same way because of the same reason of these two triangles. Now the right triangle on the right, if we were to take the area of that, they're only showing the right triangle to show that c squared equals a squared plus b squared. But on that right triangle, we know that the area of triangle is 1/2 BH. It turns out that the A and B on a triangle like this is the height. And this would be the base here, and this would be the height. Okay, that wasn't why they gave it on here, but it would just work out that way. All right. Just got important text. So if you notice, to get the area of any triangle, not just a right triangle, they have the area equals 1/2 BH here, and it's the height here. That's the height there, stuck in the middle of it. So it just so happens if we take that triangle and kind of twist this way to make it here, that's how we get why it's 1/2 BH on a right triangle, by doing that. All right? So this was the original triangle here. If we kind of move this over and twisted it so it becomes like that, that's why this becomes the B and this is the H. So why am I talking about this? Because this is the same problem. And it turns out the height of this parallelogram is not right here. The height of this parallelogram is this right there. All right? So that's significant and important. Okay, so if we bring the original problem back, our height is 4. That's our height right there. Our y is going from 5,1 to, what was the original one? 2,5. So we have 2, 5, we have y2 minus y1. We have 5 minus 1 is 4. So we have two ways to do this. We can do it visually, or we can use the coordinates to detect it. We could also resolve the 3 the same way, because we have 2 minus 5 gives minus 3. And the line was originally this way, which is a negative slope. So that works. All right? But we still know it's 3 units over. In this case, it would have been 3 units like that, going like this. Okay, so essentially we get a square here to do that triangle. All right? We're not looking for the area of the triangle. We're looking for the area inside of here, though. So anyway, our height is 4, and our base is the little 1 square here. Okay? So the area of parallelogram is not just length times width, it's base times height. So our base is 1 and our height is 4. So we get 4 square units. So that's how that one worked. All right? So the answer for B, so we kind of guessed by kind of counting the fill-ins in the very beginning, but then we methodically went through and we proved it mathematically now that that's how it works, and the answer would be 3 would be B then. Okay? So what we're going to do is skip to 5 now. Let me drag that over for you guys to see better. So 5 is a classic grade 9 problem. And again, this kind of goes to see what the issue is. YouTube is telling me that it's failed, so I'm hoping this stream is still going. I'm just going to keep chugging along. If not, I don't know what to do. I'll have to repeat this question. So I might make this the last question, especially if the connection is no good. Yeah, it's telling me it's dropping frames as well. Not sure why. This is the nature of YouTube. So so we have a cone. We can look at the illustration first. So it kind of looks like an ice cream cone, so we know immediately it's a cone. We have the 12-foot going across, so that looks like it's the diameter of the opening mouth of the cone. Okay, we're not 100% sure it's a cone, right, until it tells us it is. If it doesn't tell us it's a cone, we can't make the assumption that it is one, because that top may actually be an oval. We don't know that it's a circle or not, right? So what it's showing there may truly be an oval. In fact, it might be 2 dimensions. It might not even be 3 dimensions. So for now, we're assuming it's a cone with a diameter across its opening of 12 feet and a height of 4 feet. So first of all, it's good that both units are the same. Sometimes they could do something like 4 inches and totally mess you up, and whatever the question turns out to be, you can do it correctly, and then at the end realize, oh, it was feet and inches. So they're not playing games with that, at least yet. Not at least in terms of the illustration. So again, this illustration isn't too bad. And by the way, if we look at all the problems so far, the numbers were all convenient for us. So again, you want to shoot for that, where the numbers are making sense. Like the previous example still on the screen, it was just a 3, 4, 5 right triangle. Nothing mind-blowing, and it was simple numbers. It's not like they gave you coordinates of like 10,022 and all this other stuff. So they often make the numbers convenient for you to deal with, and I believe they are here as well. So let's look at the words now for this problem. Water is pumped into a tank that is shaped like the right inverted cone shown above. Okay, so it's a right cone because it's not slanted in any way. And if you draw a line up through the center, it will make a right angle. Okay, so that's why it's a right cone. And it's inverted because you could argue it's upside down. If you flip it the other way, and then the apex, the little pointy part, would be facing up. In this case, it's facing down. It's a cone no matter what orientation we put it in. And by the way, a good test-taking skill that comes up sometimes is while you're taking a test, you're allowed to rotate your paper. You can take your test paper and move it. You can turn it 90 degrees, 180 degrees. You might even want to hold it up to the light sometimes, although they may not enjoy that you're doing that. And as long as you do it quietly and respectfully, there's nothing wrong with that. because some problems do involve looking at something topologically, as if you're looking down on the earth, so to speak, from a bird's eye view. And some people have a tough problem taking the image in their head and moving it in their head. So the better thing than moving it in your head is actually moving it on the paper. So you have that option to do. I'm not saying you need that in this case, I'm just mentioning an extra detail. So water is pumped into a tank that is shaped like a right inverted cone shown above. The cone has a base diameter of 12 feet. Okay, so we're confirming that what I said earlier was true, and a height of 4 feet. There you go. What is the volume in cubic feet of the water in the tank when the height of the water is 2 feet? So there's two issues here. One is they don't give you, you can't use a calculator on the SHSAT, I think you all know by now, and they don't give you the formulas. On the New York State test, they do. Okay, they will not give you the formulas. So the formula for a cone, if you don't know it, you're going to have to make some wild guessing here about exactly how much is on here. And then once you understand about how volume works and how a cone works, you have to put a little spin on it, which is what they're referring to here too, because they're asking for the volume of the water at a height of 2 feet, not at 4 feet. All right, so what we're going to do for a second, we're going to take a little sidebar, and let me see if YouTube got me back online here. Okay, yes, the warning went away, so I'm still assuming we're okay. By the way, I still see a few viewers out there, so please don't hesitate to say hi. I'm here to help you guys. So, and while you're at it, please like the video and please subscribe. So I'm going to bring back this little sheet that had the shapes on it, and we're going to talk about that a little more. And the warning just popped back up. YouTube. So here's how I like to look at the different shapes. If you notice, the area of a circle is pi r squared. Okay? And the area of a cube is the length times the width times the height. The length here, the width there, the height there. So what we have on the circle is a radius, and we have the radius squared times pi. Now I'm mentioning that because if you know the area of a circle, so the question is, do you have to memorize all these? You probably should. What I'm going to try to do is try to explain a way to kind of just become one with all the shapes and figure out their volumes and areas as well. Okay? So this was a 2D shape, a length times a width. We also talked about the scenario where it could be the base times the height in the case of, say, a parallelogram that's shaped like this. So to go 3D, right, to go 3D, we have a length times a width, we add the height here. So we get cubic units on something like this. All the ones on the top are square units. The ones at the bottom are cubic units. All right? So there's something weird that happens within the circle and the cylinder. Okay? If you notice, this is no longer the area, but we get pi r squared h. So if you look at it, the ends of the cylinder are circles. So what you're basically doing is computing the area of the end and then multiplying it theoretically infinite times by the height. In other words, how many of those circles can fit between the height? I don't want to really get into that because that's more like how many angels are dancing on the pin of a head of a pin rather. But it's just a way to remember that if the end has a circle, to get the volume, you're going to multiply it by that whole height, right? The height's over here. Okay? So I went from the area of a circle to the volume of a cylinder. All right? Then what I like to do is come over to here to the cone. And I have the volume of that is 1/3 pi r squared h. So it's the same as the volume of the cylinder, but it's 1/3 of it. And I almost kind of like to draw that because if I had the cylinder, I kind of like to think of the cone in there. That should have been there. And it kind of split up into 3 parts. Now physically it's not this way, but that's how I like to look at it. And then if this is pi r squared, and this is pi r squared times the height, then the cone is pi r squared times the height, a third of it. All right? And then the sphere, I memorized the same way, because we have pi r squared here, and then we have the radius, because it's circular, the radius is not just going 2 directions now, it's really going 3 directions. So we have pi r cubed. And then because I just memorized that that was a third, then this is 4/3. It's got to be bigger. It's got to be bigger than that. And I almost kind of draw it around here like this. Okay, so at the volume, the cylinder was just pi r squared h. Then the sphere has an extra radius going a 3rd dimension. And since the cone was 1/3, then this has to be 4/3. Okay, and on that same note, the triangular pyramid is also length times width times height. If you go back to the original cube over here, okay, and a third of it. So we can almost argue the same kind of thing I did with the cylinder, I can do with the cube to get the triangular pyramid, right? And the base is going to be a square, and it meets in an apex. So there's 4 sides around here. So if I was to draw it inside of here, you could argue it makes the 3 parts again. It actually makes more than 3 parts, but if you can do the mapping between the cylinder and the cone, then the triangular pyramid just works the same way. There's a whole bunch of other shapes here as well, because there's also a rectangular prism as well, which they don't seem to do very often. And that's really just your length times your width times your height divided by 2. Because what you're going to do is you're going to take your rectangular prism or your cube or whatever, and cut it in half. So there's a whole top half you're throwing away, and then the bottom half you're keeping. So you still have the same length, width, and height, except you're tossing off 1/2 of it. You're slicing it lengthwise from the diagonals to the other side on the other diagonal as well. So you're going to throw all that away. So some of this makes sense, and it's kind of a way to just not have to memorize this kind of thing. Because even I myself, I don't use cones every day. So it just becomes an easy way to remember, oh, if I can base the cylinder off the circle, and I'll base the cone off the cylinder, and I'll base the the triangular pyramid off how the cone works off of the cube. So it's kind of complicated, but it just takes seconds at that point. And as long as we're on this slide, this could come in handy. I'm trying to remember where I got this document from in the first place. I think it's from the SAT. This can come up also on the SHSAT. We just saw the case where there's a 3, 4, 5 right triangle, and in this case this is x, right? X times the square root of 3, and then 2x, and this turns out to be a 30, 60, 90 triangle. So those don't really come up often on the SHSAT, and they will not give you a SHSAT question on purpose that requires you to have knowledge of a 30, 60, 90 triangle. But if it happens to arbitrarily / randomly come up, this is something you should know how to do. So you have 1, 2, the square root of 3. Okay? And there's just go in order. 1, 2, the square root of 3. All right? And the 1 is across from the 30. So if you just go counterclockwise, it's easy to remember. Here's another one where both angles are 45, and you get 1, the square root of 2. So again, these are both triangles that you should memorize and get used to. And the SHSAT, again, they're not going to say there's a 45-degree triangle, there's a 30, 69-degree triangle. But they might give us some sort of geometric thing where you have to figure out a bunch of angles based on something. And one of the inner shapes that you have to come to a realization about is that they might tell you it's an isosceles triangle or something like that. And it may turn out that that isosceles triangle is a 45, 45, 90 triangle on top of it. And then from there, if you know things like that, so if you might be able to compute a diagonal or the length of a side of something when they give one of these contrived shapes, whether they're asking for the length of a side or an angle or something like that. If you know these things, and there's more rules than just these two, but if you know these two, you can get a reasonable situation set up. So I really just wanted to show how you can go from the area of the circle to the volume of a cylinder to the volume of a cone. And then the sphere is larger, and then the triangular prism matches the 1/3ness of the cube. And it all just falls into place. And if you just stare at this once, twice, that's it. It sticks with you for the rest of your life. The same as something like this, 1, 1 square root of 2, 1, 2 square root of 3. It's not hard stuff. 3, 4, 5 right triangle. And there's other right triangles you should know about as well. So we just took a sidebar into this kind of thing. In fact, I might spin this off into an excerpt stream just to try to kind of touch base on some of that. And because I keep bringing up examples about number sense, about how to relate back and forth between what you're being asked to do and just common stuff like if you have 100, 12 times 10, all you have to do is add a 0 on that. You don't need to go through and do something like this. That's just no hesitation math. You should just know straight up that's 120. Just like if you know your perfect squares, you should know what that equals. 13 times 13. It's just these all comes up so often that it should just be second nature. So just trying to show you kind of a logical approach to getting some of these formulas memorized or at least maybe understanding them a little better. Even though my descriptions are not probably technically accurate or conceptually accurate. But it's an easy, quick way to you could now generate all this just by knowing that the area is pi r squared and everything else just falls into place. And knowing that this is length times width. Okay? All right, so let's go back to question number 5. And my handwriting's atrocious enough that I'm printed this one out too. And we'll end at question number 5. Let me just make sure the stream is still healthy. And if anybody asks any questions, because I have like 6 tabs loaded. No, the stream just freaked out again. Let me go back. The tab died, so let me make sure it's even alive, even remotely. Otherwise, I'm talking to myself. So while that's happening, I'm Greg from GregsTutoringNYC at gmail.com. If you have any questions about how the SHSAT works, scoring, registration, any kind of things like that, please hit me up. Please like this video. Please subscribe to my channel. If you look through it, I have dozens in 100 hours worth of SHSAT material here. Some precisely about the SHSAT, some just related to it. And I'll be pumping out a ton more. So, all right, I just got the tab back. It seems to be alive. It's showing the 12 times 12 thing, so it's delayed a bit, but and it's still telling me the stream is not. I don't have an excellent setting anymore. In fact, it's claiming it's not streaming anymore. But I'm going to answer this last question anyway. So, water is pumped into a tank that is shaped like a right inverted cone shown above. The cone have a base diameter of 12 feet. So that's our 12 here. So it means if we go from the center to over to here, that our radius is 6. Okay? And a height of 4 feet. Okay? So height is 4 feet. Let me make that better being an H. What is the volume in cubic feet of the water in a tank when the height of the water is 2 feet. So what they're doing is presenting another scenario here, where if this is coming off of here, that's lining up there, there's something over here at some point where this is 2 feet. Whoops, that should have fell down right there. Sorry about that. So it's still 2 feet. So what they want to know is, what's the water that's going to end up being in here? If we draw that completely across, what's the volume of that water right there? Okay, so how can we work through that to try to make sense of some of this? Well, one way is we don't care anymore about the original problem is what it means. Because they're no longer asking for the volume of the cone, they're asking for the volume of only this part. So now what we're stuck with, we have a problem, is we don't know the radius. Okay? But we have a proportion, whereas that if we drop down a right triangle from the very top, we have two similar triangles stuck in here. So to be clear, if we just draw that part, this was 6, this was 4. Now there's another one on there where that's 2. We don't know what that is, right? If we look in here, that's what's going on right there. So because this angle is the same, and this is 90, and that's 90, then that angle is the same as well. And we have similar triangles. We don't have congruent triangles. We have similar triangles. So that must mean if this is 4, because the 4 went from here to here, and the 2 only went from here to here. So we can set up a ratio, which is that 4 is to 2 as 6 is to x. And we would get x equals 3. Right. All right, so if we come back to the original problem, we're going to use that formula. Let me use the scrap paper again.